So back to the salt mines. So boom. Yes. Okay, I'm going to just load the model in we created together. There we go. Okay. So, ladies and gentlemen, let's go and we are going to add in a person class. How do we do that? How do we want to add in a person, a representation of personness or personhood with respect to our model. How do we do that? Yeah, so we do new agent type and we will say person. Okay. Okay. This recorder is exhibiting dysfunction, so I'm going to stop that. Okay. Now I have to watch out for my throat. Okay. Ladies and gentlemen, we're going to go to person, and we are going to lend this person a representation. Okay. And this time, yes.
This person is always capital P?
This denotes personhood. It's sort of the theory of personness. And so, yeah, it's a capital P.
If you were to look that word up in a dictionary, that would be the word you look up. And you don't get an example of a person, you get what a person is by definition.
This is indicating personhood. Okay, so what we're going to do is we're going to give this person an appearance, okay? And the appearance this time is going to be a little bit different than last time. We're going to give him an oval here. I am going to make this oval smaller, and we can do this in one of two ways. Either we can drag it like this, or clicking there, I am going to go down and set position and size, and set it so this oval has a radius, ladies and gentlemen, of 10. There you go. That oval that depicts a person has a radius of 10. Okay, great. Okay, ladies and gentlemen, partly the reason I go through these things is to get us to reverse these situations of building a model. So tell me, if I wanted to visually see, if I wanted to add a population, how would I do it? Go to Maine. The population lives in Maine, ladies and gentlemen. Okay. Okay. So I'm going to Maine, and what do I need to add to Maine? I have to drag the person into Maine. Okay. So drag person into Maine. What else do I have to do? I need to change the population. Now, I'm going to further change its name to population too. Gosh, someone over there is really good. Okay. Okay. Change its name. I'm going to change its name. But what's really of significance is that I want to change it to be a population of agents and 100 agents. Okay. Suppose I wanted to be able to have a population of different sizes for different experiments. Very common need. How would I do that? Create a parameter. Where would that parameter live? Wherein would it live? It would live in Maine, indeed. Okay, it's called population size. And what sort of parameter would it be? Would it be a double precision value, like 3.14159 or 2.71? It would be an integer, indeed. Okay, yeah, you can't have half a person. That's only in aggregate models. Okay, so we're going to have a population size, and its default value, if we don't say it, will be 1,000. Okay. Okay, now does this by itself mean the population will be automatically scaled to be the size of this? No, what do we have to do to make this actionable? What do we have to do to make it operational? What do we have to do to make this the actual population size?
You have to go back in and put population size.
Exactly. Oh, it makes me so happy when people learn. It makes me so happy. Sometimes I can't believe, they're actually listening. Okay, for the initial number of agents.
I think it's the kangaroo hops.
That's definitely up there.
Okay, well, that's good. Wait till you see my wallaby run. Okay, for the initial number of agents, this should be this dot population size, right? It's the population size in Maine. Okay, great.
Is everybody caught up? Everybody at this point? Yeah. Okay. You don't want to get too far out of step.
Okay.
So when I go to autocomplete, I don't get population size.
Okay. Ladies and gentlemen, who would like a bit, would you like me to show you something? Are we okay?
Population size.
Population size is an integer, and it's an int, and its default value, ladies and gentlemen, is 1,000. Okay? Okay.
Click on that. It'll give you your choices.
Are we okay? Okay. Okay, ladies and gentlemen. Are we ready to roll forward? Okay. Okay. So, first of all, let's. I mean, you folks are getting to be veterans. So let's go. I want to lay this population out so that they are located at a uniformly distributed over the space. How do I do that? Yeah, exactly. Okay, now where do I set the location? Okay, initial location, wherein lies that? In Maine, and where in Maine? Population. Ladies and gentlemen, we go to the population in Maine. And we're going to go to the initial location, and we're going to place the agent at the specified point. And suppose I want them to go between 0 and the width of the space for their X location. How would I say that? 0. Uh-huh.
This dot space.
Oh, good. And ladies and gentlemen, you get the name. Just use autocomplete. Autocomplete is your friend. Okay? Even if you don't remember if it said space, or you could actually do this dot and do autocomplete. Watch this. Big possibility involving this. But it's kind of nice if you can narrow it down. This dot space width. Okay? And so this is going to return some number, like 500, and then it's going to be uniform between 0 and whatever that number is. That's how to kind of read that.
Do you want space height or space cell height?
Oh, gosh, sorry. Space width. Thanks. Boom. I was overly eager in my autocomplete. Okay, and for y, what should this be? Uniform 0, comma this dot space height. There we go. Okay, so again, ladies and gentlemen, when you read this, this is a formula. Every time it's going to come through to a person, it's going to say, what's their X? And it's going to run this thing, this formula. It's going to evaluate that formula. That formula is going to return something for space width like 500 or 600 or 1,000. And then it's going to draw from a uniform distribution with minimum value 0, maximum like 600, and it's going to get a number back for X. And then similarly, mutatis mutandis for Y. Okay? Sort of comparably for Y. And then that's going to be determining the X and Y values for that person. Then it's going to go on to the next. So this is rerun again and again for each person. Okay, ladies and gentlemen.
Got a question. Just
Yeah.
one question. You said when you change the size of your actual display area?
Indeed. Would you like to see that? Okay, ladies and gentlemen, there's two things to consider in terms of space. Well, first let's run this and just make sure it's working fine before we frob it. Okay, so there we go. Do you see that? Something like that?
Is everybody caught up? Hey, could you show them the sort of that compile button?
The build?
Yeah, so aside from saving your model as you go along, it's helpful if you build it every now and again. So you don't run into a collection of errors, you can catch them one at a time.
Yeah. Yeah, build early, build often. Okay, ladies and gentlemen, I want you to create an experiment where we have only 10 people in the population. How would you do that?
Population size.
Good. Okay, so how would I go add an experiment with 10 people in it?
Oh, you want to do new experiment?
Okay, new experiment. Okay, and I'm going to say tiny population. That would be one way to do it, or I could say population 10 or whatever. And I want to change its population what? Population size. Remember the experiment, if main has a parameter, the experiment tells it what to assume for it. If person has a parameter, the population tells it what to expect for it. In any other place, the population, that person is created. Okay, so let's run that one just to sort of validate our understanding. And there we go, 10 people. Okay, happy. Okay, so just to deal, Tom, is it?
Yeah, Brandon.
What is it?
Brandon.
Wendy, okay. What is, didn't?
Brendan.
Brendan, thank you, Brendan. Sorry, my Canadian ears are imperfect at this time of day. Brendan, thank you. Okay, so let's go to main. And if we go down to main, what you'll see in main is you can set the space width and height here within main. So let's set the width to be 1,000, shall we not? Right? What do you think? Set the width to be 1,000? Okay, and now let's run it again. And now we have a width of 1,000 here, okay? So it actually extends over that window. Now it turns out that with the experiment itself, you can also set, Brendan, the width and the height for the experiment using, for the particular window to use for the experiment, okay?
When do you change that story? I missed that.
Okay, so to change space width and space height, you go in main, you scroll down to space and network, and you can set the width and the height here.
Right, okay.
Okay, but to change the actual window size,
Yeah.
so that's the logical size. To change the window size, you can do that in the experiment. In the experiment, you could set the width and the height. Okay? Yeah. Okay? That will actually set how narrow the window is, or how broad the window is. Are we okay with that? Okay.
Right, okay, I see, yeah.
Okay, ladies and gentlemen. Okay, so now we're going to go where we haven't gone before. Are you ready? Okay, ladies and gentlemen. Gosh, I got to. Kurt tells me as I get more excited, I raise my voice. And there's some truth to this matter.
That's why you can't fall behind. If you need help, call us right away.
Okay, so ladies and gentlemen. Okay, so what I'd like you to do is to go, I'd like you to go add in a diabetes state chart. So how are we going to do this? We're going to encode a person as being in one of a collection of possible states. Okay? And we're going to focus on the case of diabetes, where people can be normal glycemic, or they can be diabetic. We're going to make it dichotomous. We could have a pre-diabetic, but for simplicity, because of the time, we're going to keep it simpler. So I'd like to go to person, and I'd like to go to palette down to the agent area, and I'd like to add in an entry point that's called diabetes state chart. Okay? Are we okay with that? I'm sorry? Sure. So I went to person, and then I went down to palette, and I went to this agent area, and then I went to the state chart area. Now, we could alternatively, and I probably sit remiss for not having done this, we could have gone to the state chart palette, and it would be even clearer. But I dragged in a state chart entry point. This is accessible by either the state chart palette or from this agent palette. But I really sit remiss. I really should have done it from the state chart palette to make it more obvious. So I dragged that in, and I called it diabetes state chart. I give it a nice name because we might have many start charts for a given person. Are we okay with that? Okay. Ladies and gentlemen, the first state here is normal glycemic. Normal glycemic. And so, ladies and gentlemen, a state chart characterizes three things. It characterizes a set of possible states in which a person could be located. It characterizes the possible transitions, the possible actions that change those states. And it characterizes the conditions under which those actions take place. So, ladies and gentlemen, here's our diabetes state chart, normal glycemic, and here's diabetic. And we're going to have a transition here from one to the other. Now, ladies and gentlemen, how did I do that? I dragged in a state called normal state, and I named it normal glycemic. I dragged one in called diabetic. Do you see that? Okay, ladies and gentlemen, I dragged them a certain distance apart. Now, if you don't drag them far enough apart, you won't actually see certain visual cues. So I dragged them a fair distance, and then I dragged in a transition. And I positioned this transition so that it either started or stopped in one of those states. And you'll notice when I do so, the end turns green. And that green indicates a connection. A connection here between the two. So this indicates that the transition is coming from normal glycemic and it's going to diabetic. Are we okay with that? Okay, ladies and gentlemen.
Does it have to connect to the actual?
Yes. So if it doesn't connect, any logic will be an unhappy camper. And in fact, ladies and gentlemen, you'll notice when it doesn't connect, there's often a thing down here will say errors. And if you click on that, this will be your first encounter with what's called the problems window, where it will alert you to certain problems with the model. Okay? And the problem in this case is quite simple. We could actually click on this thing, it will clue us in where it's unhappy. Like it says, this one is not reachable. This is a hanging transition. We want to connect it to that. Are we okay with that? We connected it through, and notice it's connected with green on both sides. That, ladies and gentlemen, is an indication that it is connected. Okay? So green is the color. Okay? Football is the game. Okay. You see that? So those two are connected. Okay? So ladies and gentlemen, here's the color. We've just connected. So let me reemphasize. State charts are used to characterize the set of possible states a person could be in with respect to some particular concern. Here it's with respect to diabetes. They also characterize the actions by which that state can take place and the conditions under which that action can take place. In order for someone to become diabetic, they have to be in a normal glycemic state. And if we go look at this transition in more detail, first of all, we should give it a name. The name of this transition we'll call becoming diabetic, or it could be called contracting diabetes or what have you, developing diabetes. I'll call it becoming diabetic. And I would suggest, as a general rule, showing a name for it. Okay? Becoming diabetic. Do you see that? You could do show name, and then you can drag this around. Okay?
How do you show it?
So it's up here, associated transition showing it. Are we okay? Ladies and gentlemen? Okay, now, you'll notice right now it says it's a timeout, and it's a timeout of 1 year. Now, I want to make a visual point here, so I'm going to leave that for the moment, and we're going to go do something else. Ladies and gentlemen, this thing that I'm about to do may seem modest, And in fact, in the current situation, it may not seem even fully necessary, but it will highlight a technique for capturing certain types of situations that will end up being very useful and versatile for you. So it's a seed that will grow into a tree in other parts of the model. So I'd like you to introduce into the model something that was brought forward just 2 hours earlier within one of the questions, okay? And it is the concept of a variable. So I'd like to go to the palette and would like to go here to agent, and I would like to add in a variable. Okay, Kim had asked about this. And this is in person, and I'd like to call this variable. Okay, now this is a thing of great significance. Kurt, should I just call it color with the dictates of the American Imperium, or?
I would.
Okay, fine.
Remember we had small S-sex and big S-sex? Well, we also have the same thing for color, because this was developed for the U.S. market. It's developed by Russians, but for the U.S. market. so they don't really care, because the company who builds this is a Russian company, so they don't really care how you spell it, but they chose America because their marketing environment is American. So color, there's a type color, and so we've seen this before, red and yellow and orange and stuff. Those are all of type color. If you look it up in a dictionary, you'll see those options. So here is an example of a particular instance of color, my color. And so basically we have to choose, are we going to spell our instance O-U-R, but then our type is going to be just O-R because we can't control that.
The type color with a capital C is something that is from Java. We can't change it. And Java is produced.
We should put a U in this one because it shows that we can control it. It's another reason to us that indicates that it's
Should we put a U? The Canadians would be happy for a U.
Everybody in this room would be happy with
Okay, let's put a U. Let's put a U. Color, okay?
Fight the man, right?
Okay.
I think you'd like to have to use food
Okay, ladies and gentlemen. So, what will the type of this be?
string.
So, one of the TAs, please keep track of what goes on, so when he comes back, you can help him.
Great.
Okay, actually, the type of this is other, and its type will be none other than color with a capital C. This is the thing we can't change. This is
Type will be other.
Java.
Other than colors.
It has to be, the type will be other, and it's not one of the listed types in short, and it's called color.
already exists. They're useful documentation.
It's a good question. It's a fine question.
What's the question?
So how do you know it exists, the type? Like it's not listed?
It's not, there are literally thousands of types that are available from Java. And suffice it to say that this is why I run, one of the reasons I run my boot camps, is to teach principles like this. It's an extremely common need, and so I like to teach it. Okay? And I wish there were complete documentation of this. You will see dozens of my models using color. You will see quite a few of their models using color that are built in, but I'm not sure it ever says, use color, for things where you want to set the color. It's unfortunately, I think it's an under-documented component of it.
Can I just say one thing to that? Speak to that point
Sure.
for a second. So this is true even if you're just doing a straight-up development in Java. Because it's object-oriented, you've got objects that inherit from other objects, and each object itself will have certain methods implicit in those objects, and maybe you don't know what those methods are. And so what developers will sometimes do if they want you to code in their framework is they'll give you what's known as an API. So sort of describe these are the different components.
Application programming interface.
Yeah, so you can navigate through that, and it shows you the different objects, and so it's kind of like a dictionary that you can use. So if you don't know the letters, if you haven't learned all the letters A to Z, or A to Z, right, then you don't know which ones to use. And so there'll be a list of that, and there actually is a website where you have access to sort of the API for for any logic. But what we're doing here is we're giving you sort of a Coles Notes version. Like the number of letters in that is very large, and so we're saying these are the ones that you'll probably use. If you want to be able to go and find more of those, we can provide the website.
Yeah.
And sort of show
And
you.
actually, Joe,
Yeah,
there's
just so you know, Coles Notes is not a Australian thing.
Oh. Fair enough.
I'm pretty sure I've seen it on enough American TV shows to get the meaning of it, but actually.
Yeah.
it's a condensed,
Condensed version. Yeah.
condensed,
So
but
people over there got enough. See, I watched enough American television as a child.
so we'll see why it starts to become. I mean, it's not as black and white as you might think, so to speak. There's more color to it, because it turns out that we're going to come to a thing where this color variable is used to dictate the color, and it will kind of make sense that there's something called color, and if you looked it up, there'd be something called color. If you weren't sure if there was a color, you could do control space here, and you'll be fine that there's a thing called color once it comes back for me. Color. Come on, color. There it is, color. Okay, there it is, color. But I understand your pain, and it is a concern. Okay, so what's going on here? Color. Okay, and the initial value will be black. Okay, black. Okay, so it's going to be black initially. Okay, ladies and gentlemen. Now, how would we change it so that their visual appearance is black? Whither do we go?
What are we actually changing?
We're
What's the
gonna-
color for?
Okay,
dot. You
we're
have
going to
to
be
go select
changing
it.
their visual appearance. Where is their visual appearance right now?
You have to select a person and the dot and the.
We have to select this dot. This is all in person already.
Body.
And we want to go up, yeah, but we want to go here. And I'm trying to show you different shapes. Shape body was for that person shape. Now we just go to oval and we scroll down to appearance and we set, okay, now this says fill color. How are we going to set this to be that color variable? How did we do that before? How did we make it depend on the sex? Yeah, we changed this thing, we frobbed it. Remember that? Okay, we frobbed it. We went to something like that. And what do you think we want it to be if we just wanted to use this color variable? What do we have to put here?
Variable, and the question is whether you put this or item.
Yeah, this dot color. Item is only used in statistics.
And self is not.
Self is only used in that thing where the person's characteristics get initialized, and then it's used in some stuff in discrete event modeling, which you don't want to know about right now. But this should be this dot color, my color. Okay, my color. I mean, those things are very rare with the this, except in that, the self, except in that circumstance, and then a few things in discrete event modeling. Okay, this dot color, ladies and gentlemen. Ladies and gentlemen, this dot color. Are we okay with that? Let's run it. What should we see if we run this thing? Yes. Okay, so let's run it, and we will see before us. Okay? A set of black spots, right? Now, ladies and gentlemen, I would like to lend color to this frame. So, out black spot. We will go now and set its color, okay? Okay. Okay, so how are we going to set it so that I want it to be set so that in normal glycemic it's green and in diabetic it's red? How would I do that, ladies and gentlemen? What would I do? Yes, so ladies and gentlemen, remember we did this before in response to Julia's questions many hours ago, before lunch, which was hopefully not the highlight of the day. Okay, ladies and gentlemen, how did we set this color? Yeah, we set its fill color, but all we have to do here First, oh yes, we set the fill color for this thing. Quite right. Tom is right. So we're going to set this. Okay, you didn't like green. You didn't like lime. So you want to do green, right? Okay. And this one, let's set it to red. Are we okay with that? Okay. Ladies and gentlemen, now does that by itself, is that going to change their color from black? No. So how are we going to change it so when they come in here, they are changed to green? And how are we going to change it so when they come in here, they're changed to red?
Entry and exit actions.
Entry and exit actions. Entry and exit actions. Kim has the idea. So Kim, where do we go? Entry and exit actions for what?
Entry is the black one and exit is the...
Okay, so we go to this, ladies and gentlemen, we go to the state, and what do we type for entry action? Okay, this dot color equals what? Oh, gosh. This dot color equals green. We're going to set it to be green. And for this, so for the entry action, so when someone comes into this state, the color for them will be set. Now, how does setting that color change their appearance? Well, we just set that up here. The fill color will be given by this value color. So whenever it changes, it's going to change the fill color. Okay, so that's right. So, ladies and gentlemen, for this normal glycemic state, we're going to set the entry action to be this, equals green. Now, you'll notice that there's an ugly fact here. There's an ugly thing that mars the beauty of this command. What is that ugly thing? It's the semicolon. Ladies and gentlemen, as a language, Java is afflicted by cancer of the semicolon. And unfortunately, it confuses people in these classes. This is one of the reasons I feel really some regret having to teach Java. So the rule for semicolons, when do you need them, when do you not? That's a common question. Very common question. Why is it sometimes, like up here, I didn't need a semicolon, but down here I do? So the rule is very simple. It's a very simple rule. If what it's asking for is just a value, it's just a value. It may be a number, it may be a string, it may be a color, it's just some particular value. In other words, if you're not trying to tell it do something, if you just need a value, you just put it in, there's no semicolon needed. Like how wide should the circle be, or what color should it be? What should its location be? You don't need a semicolon for that. It's just a number, it's just a value that it's computed. By contrast, if you're giving it a command, you're saying, make this happen, make its color green. You're saying, do this. That's a command. And the semicolon here is like an exclamation point. Do it, it's an imperative. Okay, semicolon. Semicolon, I regret to say, is needed. Jeff?
So this like change the color to green.
Yeah, say change my color to be green. Boom. It's not computing a value. It's not asking for the action. It's not computing a value. It's an action. It says perform this, do this, make this happen. This is the command. And so you need a semicolon. Jeff?
Yeah, the way I think of it is they would have used an exclamation mark, but they'd already used it for a not. That's how I remember it. It's an exclamation mark.
It's like an exclamation mark. Do this. Okay, I'm sorry to say, but that's the rule. If you're just looking for a value, don't worry about the semicolon. You don't want a semicolon. If you're telling it, do this command, particularly for actions, those are things which demand, almost militate, they command, then you put it in. Now, what should the action be for diabetic? Can anyone generalize it? What should it be here? This dot color equals red, semicolon. Now, Build early, build often, ladies and gentlemen. Build the model here. Okay. May we run the model? Oh, by the way, if you build this model, it should say builds completed successfully down the lower left, something like that. If it does not, if it's unhappy, grab a TA. Okay? If, like, for example, let's suppose I said this dot color equals RE, and then it will be very unhappy. It'll say there's an error. It cannot be resolved for a variable. If I go in the problems window and I click, it will bring me to where it is and I say, oh, I forgot RED. Or if I said, you know, this dot color without the U, and I typed it, it'll be unhappy too. Color cannot be resolved. And I say, oh, you know, this is Australia. We should do U. And there it is. And the Canadians would be happy. Okay? Are we okay with this? Okay. Ladies and gentlemen, so can we run the model? What do you think will happen now? Okay. Okay, so let's try this. Boom. When do they change? Do they change one by one or all at once? All indeed at once. Let's run it with a large population. Watch this. Boom. Okay, ladies and gentlemen, what we're witnessing there, ladies and gentlemen, is an aspect of this. It's actually, we specified a timeout. We specified an exact time by which they should go, okay? But ladies and gentlemen, can I show you something? This timeout is in a way one of the most general of the options. It's a very general option, but most people don't realize it. They think, oh, it's fixed, it has to be a fixed value. Let's change this to be 10 years. You'll notice when I ran this already, you'll notice time is ticking on the lower right. Remember, the yardstick of time is 1 year, so watch this. Boom! It passed 1 year and it changed. What if I changed it to 10 years? What do you think would happen? It'll take 10 years, so watch this. Okay, here it goes, and here it is. It's ticking. Look at that. Past 2 years, past 3. Okay, we're getting into, okay, it's approaching 10. Watch this. Boom! All gone at exactly 10 years. But what if we put in, ladies and gentlemen, instead of a fixed number here, what if we drew it from a distribution? We could pick an arbitrary distribution. Do you remember how to define a custom distribution in any logic? How do we do that?
One of those icons.
Yeah. It's we could do it in the, well, yeah, we could do it up in this custom. Sure, we could draw from a distribution there. That's true. But if we wanted to draw it from that would be a parametric distribution. If we wanted to draw it from well, sure, let's draw it to save time. Let's draw it from up here, and let's draw it from a triangular distribution with a minimum of 5 years, a maximum of 30 years, and a mode of 20 years. Okay, there's a triangular distribution. It's going to sample from this triangular distribution. Okay. Okay, and I'm going to say 20.0 just to avoid giving you bad habits that will bite you at some point. Okay, I'm going to say triangular. Oh, look at that! It truncated the zeros. That's the most humble. Okay, ladies and gentlemen, we now have the timing associated with this being drawing from a triangular distribution. What do you think will be the implications of this? Anyone? What are the implications if we draw a timeout from a distribution? Do you think everyone will change at the same time? No, for each person it will be different. When they come in here to this preceding state, it will figure out when they should leave. Mark my words. When they come into this preceding state, it will figure out what's the timeout by drawing from this distribution. So let's run it. Ladies and gentlemen, the important point I want to convey is one that's not obvious to most. Notice, why isn't anyone changed yet? It's time 3, time 4. The minimum was 5, right? And now people are starting to change. So a timeout, far from being a rigid thing, it provides you with a way of drawing the timing of when people leave from an arbitrary distribution. Okay? It's very useful. You can draw it from a custom distribution that is based on some empirical data. If you want to be based on empirical data, you could even use a custom distribution object, just like we did to draw males and females earlier. Ladies and gentlemen, I'd like to show you another type of transition, though. Okay, this will be a rate transition. So let's go there, and let's specify a rate transition. Okay.
We're talking about your ears burning?
So you can use the incidence.
No, my throat is burning. Okay.
We're almost done, Nick.
Now that means something.
So you use the incidence rate?
Register.
Yeah, you could use the incidence rate. So ladies and gentlemen, that's a good point, Roberto. Yeah, exactly. For the rate transition, what we're going to be specifying is a hazard rate. So this is a certain chance per year in this case. So watch this. With the rate, you'll notice we could specify, is this per month, per week, per year, and we're going to specify a rate of 1.0 divided by 10.0. So on average, it will require 10 years. The distinguishing feature of this hazard rate is that it is going to be the same kick of the can. No matter how long you've been in the state, by default, you're going to have the same chance. That's what a fixed hazard rate is going to mean. So if you've been there 1 year, you've been normal glycemic, or 20 years normal glycemic, it's the same chance per year of leaving. This is a per year. This is a density for whom that's a meaningful concept. So this is a certain chance per year that you'll leave. Okay?
What about age? I know.
Well, yeah, we could actually make it vary by age. We could, in fact, make it vary by sex. And we are going to make it before the afternoon is out. We're going to make it depend on another risk factor. Okay? Are we ready for this? Okay, ladies and gentlemen, let's give it this hazard rate of 1 divided by 1.0 divided by 10.0. Now, I'd like to tell you an unfortunate fact. I'd like to tell you an ugly fact. I'd like to tell you a fact that has kept some computer science students up for hours, fruitlessly trying to get their program to work. And I'd like to tell you a fact that has caused some anti-logic modelers some grief. Okay?
Are you ready?
So, ladies and gentlemen, please avoid this. You'll notice I'm putting in these point zeros, and you may wonder why. If you put 1 divided by 10 here, you would think that's the same thing. 1.0 divided by 10.0 and 1 divided by 10. It's not in the world of Java. It's not in the world of languages from which Java comes, whence Java comes. What this means in Java is the integer 1 divided by the integer 10, which basically is asking how many times does 10 go into 1? And the answer is 0, with a remainder of 1. But it's 0 times. So the value of that in Java is 0. You do not want integer division. You want floating point division. So you want this. And actually, it's enough to even make one of them 1.0 will be fine. But if you put 1 divided by 10, if both are integers, it's bad news for you. Okay? And computer science students are tripped up by this. I found bugs in my students' models because of this. And it's not any of the ones in the room, I think.
If it was,
Okay.
It's a bit like case sensitivity for numbers.
Okay, ladies and gentlemen.
So you always have to have numbers points.
Well,
if you want to resolve
it's just safe to do it. I'd like to teach my students habits that are more robust.
Okay. Yeah, no, it's a good practice.
Yeah.
Yeah, exactly. It's a kind of best practice. Okay, so ladies and gentlemen, here it is. You notice some people getting diabetes sooner. The average time is 10 years. 1 divided by, it turns out that the hazard rate, the mean time in that state is 1 divided by that, if that's the only outflow. That's the only way out. But you'll notice even at 15 years, some people still haven't gotten diabetes. Some people get it early, some people get it late. It's exponentially distributed for whom the residence time, for those for whom that's a meaningful concept. their time in that state is exponentially distributed with an alpha of 1 divided by 10. But that's what this rate means. It's a certain chance per unit time of leaving. Okay? Now we're going to take this in a direction we haven't gone before. Ladies and gentlemen, I'm going to save this model as version 1, and if anyone has had trouble following along, they can now download this model from the site in just a moment, okay? And I will go post it as we speak. Here we go, and there we go, boom, and it is up there on the site now. Okay, ladies and gentlemen, if anyone wants to, they can download that and the TAs will assist. The minutes are ticking, but I have promised you something. I have promised you that we're going to have interacting state charts. In fact, it's embedded in the name. So steel ourselves. The best is yet to come. Okay, so I want to add another state chart. Whither do I go?
Sorry, can I have a question? This way, you make sure that everyone will eventually turn diabetic. Is there a way to control that? How many percentage of the population will never turn diabetic?
Yes, there are several ways to do that. The question is, in my mind, is that an emergent feature of the model or is it something structural? So if it's an emergent feature of the model, maybe that's because of competing risks. Maybe it's because some people die before they become diabetic. In which case, the natural way to capture that is to simply have a mortality process, something which we'll be seeing probably tomorrow. People can die, and some people die before they have diabetes. That would be very easy to, if I wanted to, I could do that in the remaining 20 minutes, and you could see, some people die before they become diabetic. If it's a structural thing, that some people are somehow in this state that is not subject to this condition, and it's not an emergent feature, it's a feature of the mechanics of the system. You could have a state for people who are immune to that particular malady, in a state who are subject, and the ones who are subject would be at risk of transition, the others would not be.
Okay.
If you see what I mean.
Yeah.
Any other questions? Wonderful question. Question? Kurt.
I just wanted to share one thing, which is the choice of a behavior being like emergent from the model or programmed directly into the model. So that's not only is that a question of what the true scenario is. Like, so in this situation, they gave an example of how it might be within the model. Like, some people come from populations where they won't progress, and so you would just put that directly in the model, and then maybe the reason why they're not progressing is because they're dying before. So there'd be a different way to do it. But you might actually know that there's some other reason why this particular population is not getting it, but you've made the decision that your model is not going to be complicated enough to take that into account. So you just say, we know that 10% of the population doesn't do it, and so you're going to sort of exogenously say, this is the case. And then later on, as we go through this process of incremental development, you might add the complexity in that state.
Mm-hmm.
Yes, awesome answer,
Yeah.
Absolutely, yeah.
Okay. So good discussion. This is an important point about what's incorporated in the model, what's left out, and how that evolves over time. And one of the most important points that I want you to carry away from this boot camp, even if you never come back after tonight, because you didn't leave, okay, is the recollection that these sort of models are best built incrementally. They're best built incrementally, as Kurt referenced, because you learn, by building them incrementally, you learn how each successive change, how it changes things, how it modifies the behavior of the model. You learn from the model more effectively if you build it incrementally. Also, if there's a bug, you find it sooner by building it incrementally. Also, you can show it to people and get guidance about what the next priority is incrementally. And so you can get guided by other team members in a way that might end you in a very different state a year from now with much more insightful features because you've shown it along the way and gotten new guidance. Modeling is a learning activity. It's not just building some fixed planned model. It's a matter of learning as we're doing it and take into account that learning to shape our thoughts of what gets done next. And building models can be quite, you can avoid risk by building it incrementally. Also, we're much worse at estimating how long it takes to build a model if we envision a big model. If we're just adding a few pieces at a time, often we can be pretty good about estimating how long that takes, 2 weeks, 1 week, 3 weeks. Whereas if we're trying to envision a big model, we can fool ourselves easily and by thinking it can be done in 6 months where it really takes 2 years, or vice versa. So it can be much more effective if we build it incrementally, okay? Remember that if you flee. But remember if you don't flee too, okay? Okay, ladies and gentlemen, let's use the remaining time. We're going to add a new state chart. How do I do that? Whither do I go? We want to add it in to the person. So where do we go to add it in? We go to person, good, that's a good start. Where do we go then? Okay, state chart palette, indeed. And we're going to drag in here, ladies and gentlemen, nothing less than a weight state chart, okay? So it's going to be called weight state chart. Now note this point. This is a point of some significance. State charts depict categorical, sometimes ordinal, but often categorical divisions, which are collectively exhaustive and mutually exclusive with respect to particular concerns. So there's going to be one state chart that depicts your state with respect to diabetes, and another one that's going to depict your state with respect to weight. And so we're going to drag into the weight state chart a state called normal and underweight. We're going to drag in a state called overweight, and we're going to drag in a state called, ladies and gentlemen, obese. Okay? And we're going to place betweenst them a set of transitions, okay? Okay, and now I'm really triaging because time is limited and I want to let you folks out. Okay, we're going to put in place some transitions. There's going to be a transition from normal and underweight to come on, there we go. Arrow keys are your friends in AnyLogic, so you could drag these forth, okay? Okay, so we're going to have this, and this is going to be called becoming overweight. And we're going to do show name. It's good practice to show the name so that people understand what that transition means. Sometimes there may be several causal paths between one state and another, and by giving them appropriate names, you can get greater clarity about your model. Remember, models are used in a human theater, and by making a model transparent, you can enhance the chance that you will build up buy-in and support for that model by allowing it to communicate with people that otherwise wouldn't understand it. So for the transition from overweight to obese, I'm going to call this becoming obese, okay? And both of these, I'm going to show the name. Now, they will each become a.
You have to click on the transition first.
Oh, thank you, Kurt. Yeah. Thanks. Okay, so ladies and gentlemen, we're going to have for each of them a characteristic that is going to. Right. Okay. Okay. Great. Okay, so for this one, for overweight to obesity, we're going to make that a rate transition, and it's going to be a hazard rate of 0.2. What would that imply for the mean amount of time, the average amount of time that they spend in the overweight state? If it's a hazard rate of 0.2, the average amount of time that they spend there is what? It's 0.2 per year, so the average amount of time that they spend is 1 divided by the hazard rate. And what's that? 5 years. 1 divided by 0.2. It's a fact about the distribution. If you look up the exponential distribution, you will find that the mean time, mean residence time, mean sojourn time in that state is 1 divided by the alpha. Okay? It's a fact about the distribution that has little directly to do with any logic, but it's a feature that you know. Where would these, from whence would these hazard rates come? Well, we draw them from things like competing risks analysis or survival analysis or recurrent events analysis to estimate these rates. They come from, for example, biostatistical studies, and we'll place them in there, or we'll derive them from the data that's available through similar sorts of analysis. Okay, ladies and gentlemen, so these rates, this would be a rate of 0.2 per year, and for becoming overweight, I'm sorely tempted, but we're going to have to leave it for tomorrow, to make this depend on their age, as Roberto suggested. We could make it very easy that this depends on their age, but it will be a bridge too far for today, I think. Okay? So we have other fish to fry for the remaining minutes. Tomorrow morning, we could start with that and make it depend on age. Okay?
Yes.
Ladies and gentlemen, so becoming overweight, we will simply make this a rate transition, and we will make it a rate transition of 1.0 divided by 40.0 per year. So on average, they will spend 40 years in the normal and underweight state. Some may leave early, some may leave later. And because of the time, I want to get you released from this activity in a timely fashion. Okay, ladies and gentlemen, normal and underweight, overweight, obese. Now, ladies and gentlemen, I would like to make the hazard for going from a diabetic status to a non-diabetic status depend on their current weight. So if they are normal and underweight, we're going to have one rate applying. If they're overweight, there's going to be another rate applying from normal glycemic to diabetic. And if they're obese, there's going to be a higher rate yet. How would I do that? How would I have it so that this state chart on the left, the hazard rate for them becoming diabetic, if they are still remaining normal glycemic, how would I have that rate, that hazard rate for going here to here, depend on their current weight? I could write some conditions into the transition. And true enough, Tom has spoken. That actually would be one way to do it. But the condition there could be a bit messy about which status I'm in. I could do it. I could do it even nicer through a function. But now I want you to think about a mechanism by which we communicated what state we were in here for another purpose. What could I use to communicate? How did I communicate what color to use for my appearance? I used a what? A variable. Could I use a variable that would communicate the hazard rate that should apply here when I'm in this state, or this state? Could I have a variable that would encode that? And when I change states, we set that variable? Yes, we could have a weight and we could have a hazard rate of becoming diabetic. So let's do that in the closing minutes, okay? So ladies and gentlemen, okay, let's add a variable, okay? Okay, so we go to the palette and to the agent area of the palette. The time is a ticking, and I've got my eye on it, okay? We're going to drag in a variable, and this variable will be called developing diabetes hazard contribution from current weight. I know you won't like it, and Kurt probably detests it, but that's okay. Here we go. Okay, here Here we go, and let me spell it out for you. Hey, oh my gosh, it's not copying it properly. Okay, there we are. Developing diabetes hazard contribution from current weight. We're going to have several contributions to their chance of developing diabetes. This is just going to be one of them. Okay? Okay, ladies and gentlemen. Copy, paste. Is your friend.
You changed though, yeah.
And that's the reason why you use auto. You don't have to type it, I'll type it for you.
Yeah, that's good.
Yeah, autocomplete is your friend. Okay? Developing diabetes hazard contribution from current weight. Okay.
There is no restriction in the size of the leg?
No effective restrictions. I think there might be a limit of several thousand characters or something like that. Yeah. Okay, ladies and gentlemen, so how are we going to set this? How are we going to, okay, where should this be used, first of all? In becoming diabetic. And because I got to keep this quick, we have just over 5 minutes to go. So I really want to keep this quick. So for now, I'm just going to put it directly in. Developing diabetes, and have it fill it out for us there. It's just going to go directly in there. I'm sorry to abuse you in this way. Okay. Ladies and gentlemen. Remember, autocomplete is your friend. Please don't use typing. Please autocomplete. How do I do that? I go here and I space developing, control space, and it will fill it out. You'll notice I misspelled it. I should have called it developing diabetes hazard contribution. It should say contribution, and I should really have developing there. Okay. Okay, ladies and gentlemen, are we almost ready? Okay, now how are we going to have this variable, which is going to dictate their hazard rate of coming here, how are we going to have it change for their weight? What do we need to do?
Should we have a this or something?
Oh, thank you. It should be this to be consistent. Thank you, Joe. Thank you. Yeah. You actually, the secret is you don't actually need this all the time, but it's better if students learn to put this in because it will avoid certain problems. In certain cases, it'll allow you to avoid problems by being explicit about it. So thank you, Joe. The class should thank you because that's an important point. Okay, so how are we going to set it so that we have different rates applying for this through this variable? How are we going to set it? Where are we going to set it?
On entry.
Yes, on entry for each of these states, we're going to set this variable. So, ladies and gentlemen, for this first place here, this dot developing, don't type it, we're going to set it to be 0.001. And does this need a semicolon or not?
Yes.
It does, because we're commanding it. We're saying, set this thing, set it. Boom. Just like that, okay? It's going to set it. Boom. Okay, for overweight, ladies and gentlemen, we're going to set it to a much higher value, unfortunately. We're going to set it to be 0.02. And for this obese, we're going to set it to 0.08. This is hazard rates. We are setting the hazard rate to use here by the appropriate weight here. Do you see that? Okay. Okay. We're going to do one final thing. Okay, one final thing. Ladies and gentlemen, I'd like you to add another variable that will be called visual size. This is just going to make it clear visually what's going on. One more variable here. One more variable to communicate the visual size. Are we okay with this? This is going to be a double value, just as the hazard rate is. Visual size. Are we okay with that? The visual size, its initial value, we could set 1.0, but it's going to be visual size. And we are going to set on the entry action something that determines the visual size. So we set this, and ladies and gentlemen, for normal for normal and underweight, we're going to set this dot visual size equals 5. It should be called visual radius. Forgive me. For overweight, so TAs, pay attention. 5.0 for normal and underweight. For overweight, ladies and gentlemen, this dot visual size equals 10.0. And for obese, this dot visual size equals 20.0. Do we need a semicolon or not? Yes, we do. We're commanding it. We're saying, make the visual size this, make it that. Are we okay with that? Okay, and there's just one final thing in that crowning jewel. Okay, are you ready? Okay, we have to make their visual size. So it's 5.0, 10.0, and ladies and gentlemen, for obese, 20.0.
Sorry, I missed, what is the value for the developing diabetes outlook?
So for those, the first is 0.001.
No, the initial variable.
Oh, the initial value, I actually secretly didn't set it. I'll set it to 0.
Okay.
Okay, ladies and gentlemen. And how are we going to set it so that the radius of this circle depends on the visual size? Can anyone tell me? Okay, so I go click on this shape, the oval, and where do I go here? Under position and size, and what do I look for? Radius, and I change it to be this thing. I can't do it here. This is just for fixed values. I have to do it so it's recomputed. And what do I say? To make its radius be the thing called visual size, what do I set it to? This dot visual size. That's what I want this radius to be set to. Ladies and gentlemen, this dot visual size for the radius here, it's in the position and size area. And with that, ladies and gentlemen, we finished our example. We build, and let's run her. Are we ready? Are you ready to run it? Okay. Okay, build. The TA stand ready for one final deployment. Okay, and I'm going to run it with a smaller population here. And what's going on? Can anyone tell me? I'll run it with a larger population. I'm going to run it with a large population indeed. What's going on?
People get fat and then they turn red.
Yeah, that's a pithy statement, but inaccurate. Okay, so what does the visual size represent?
Sorry.
Their weight.
Weight, yeah.
What does the red versus green represent? Diabetic not. And you'll notice that there is a higher preponderance of diabetes among those individuals who are large. These individuals who yet remain svelte, these individuals are unafflicted predominantly by diabetes. Diabetes is predominantly associated with individuals who are higher weight, and that's no mystery. Why is that? It's mediated by this hazard. When we're here, we have a very low rate of hazard rate going from normal glycemic to diabetic. As we progressively gain weight, we have a higher rate indeed, and a higher weight down here. So what we have captured, ladies and gentlemen, is two different conditions, two different comorbidities, as it were, associated with obesity and associated with diabetes, where they're each crisply characterized in a fairly decoupled way, a fairly independent way with state charts, but there's interaction between stuff. A person progressing through successive levels of risk and weight influences the risk of developing diabetes. And yet we can capture a person's history with respect to weight and with respect to diabetes in a very natural way by having these as fairly independent state charts. So a given person at a given time is going to be, if we were to run this and we were to drill down, a given person at a given time will be in exactly one state, ladies and gentlemen, relative to each of those state charts. So if I were to drill down here, here's a person who's normal and underweight and normal glycemic. Here's a person who is overweight and normal glycemic. Here's a person who is obese and normal glycemic yet. And each person will be in exactly one state for this state chart, another state for that state chart. But they are interacting via this variable. Because this person is obese, they have a very high rate here, high risk of becoming diabetic, while other individuals have a lower risk of becoming diabetic because they are remaining at lower weight status. Okay.
Becoming overweight but not becoming obese.
Why is there a number near? So what you're seeing there, I think, we'd have to go look at your model here, but
You had it as well, like there was a blue number under becoming
yes,
overweight.
the blue number indicates in what time they'll go out via that transition. So if they're remaining in this state, this is the amount of time it will take for them to go from this state to that state, because they're not yet in this state. So they're only eligible for this one. And when they switch there, then it will count down this, because now they're eligible. So there was a question when I run this thing, if I go look at the level of a particular person, you'll notice that there's a number there for them becoming overweight. And what this is saying is that in 50 years, and just under 40 now, they're going to become overweight, absent anything else that preempts that. Tomorrow we'll see some things that preempt. And now when they become overweight, now they're eligible to become obese. And that blue number counts down how long it will be until they leave by that other transition if nothing else gets in the way. Okay? So that provides us an indication as to the coming dynamics. Yeah. Okay. Good. We've come a long distance. Thank you so much. Great. So grateful for your patience. I appreciate your stalwartness in coming through this. We've covered a lot of ground today, and we're gonna have some exciting stuff for tomorrow. Okay. But you've covered a lot of the basics of how you build these models. And suffice it to say, what you've seen today, you'll repeat over and over again, is your staple for modeling. There's lots of things to come on top, but this is some of the most standard repeated stuff you'll do again and again and again. So this is not just learning more and more and more. This is learning the core basics of how we build models. And we'll be tweaking around the edges and having a couple more big features. But a lot of what you've seen today is the essentials. Jeff?
We just want to try to agree on a start tomorrow. This will be open at 8. We scheduled it, I think we said 8:30. I'm quite happy people to vote whether you want to start at 8 or 8:15 or 8:30. Is there any feeling here in the room? Hands up those who want 8 o'clock. Who wants 8:30?
Starting 8:30.
Who wants 8:15? 8 o'clock has it. 8 o'clock?
The lecture starts at 8.
The lecture starts at 8, yes. Well, 8 o'clock.
Yeah.
It starts straight away, so I'm open.
So we have
Yeah.
I actually have a question.
Yeah, I'm happy to answer questions. Yeah.
I don't still quite understand the logic of the variable